So, what have we learned so far? We have talked about the prisoner's dilemma game. The first point about the prisoner's dilemma game is that it is a simultaneous move game, something we just mentioned. So, a simultaneous move game is one where the individuals do not have any information about what has been the move made by or what has been the action taken by one player or the other. A lot of the games or a lot of situations that we will look at will be of this nature, simultaneous move games. For example, if you go back to your Cournot equilibrium, that is also a simultaneous move game. The other thing to note is, by and large, there is no difference whether you look at a game in extensive form or normal form when it comes to a simultaneous move game. As we shall see later, that only when there is some dynamism in the game, that is when players take actions which are observed and then reacted to, is there a difference between the normal or strategic form and the extensive form. We have used a concept called the dominant strategy equilibrium. It seems like a very powerful concept, and certainly whenever we find or we can find dominant strategy equilibria, we should certainly be very comfortable with predicting the outcome of such games. So, in other words, we should say, or mostly say, that if there is an equilibrium in dominant strategies, then we think that is the equilibrium that we should predict. The other issue is actually quite interesting. Now, in all of the economics that you have studied about consumers and producers, none of them are actually interested in the welfare of others. The consumer tries to buy at the lowest possible price, and the producer tries to get the highest possible price. There is one interesting feature about the prisoner's dilemma. Generally, in most of economics, selfish behavior leads to the greater good. Generally, in most of economics, selfish behavior leads to the highest level of welfare. We have shown this when we talked about demand and supply, where interfering with the market mechanism in the form of price controls or quotas would only reduce the welfare of the producers and the consumers. Here, unfortunately, we find that in the case of small groups of people, selfish behavior leads to get to equilibrium or outcomes which do not maximize welfare. If you remember the prisoner's dilemma, by being selfish and being strategic, both the players end up with 4 years in jail. If somehow they had been able to communicate with each other or to be able to somehow get to a situation where they always deny, then maybe they would have been able to get away with 2 years in jail each. Now, this situation should also somewhat remind you of the Bertrand equilibrium. What happens in Bertrand equilibrium is, because both firms compete so hard, they end up in a situation where they charge a price equal to marginal cost and they find themselves without any profits. So, in each case, in the case of the prisoner's dilemma or in the case of Bertrand equilibrium, you might worry or you might wonder, why can't they cooperate? Now, what we can show is that if the game is repeated a number of times, then certainly there is the possibility of cooperation. But that is beyond this particular course. So, if you want to think about it, we can suggest you certain other texts.